This is my lab 2 on projectile motion. This is my table of contents. The purpose of this lab was to analyze how air resistance or drag affects projectile motion. To do this, we used two modeling tools, Tracker and GlowScript. Tracker is a video analysis software that can give us position and velocity data, and GlowScript is a computational model that can predict ideal projectile motion. This lab is based on the fundamental principles of Newton's second law and the kinematic equations for position and velocity. Throughout this presentation, I will refer to the three formulas shown, the position update formula, the velocity update formula, and Newton's second law. Our prediction is that the computational model that incorporates air resistance will more closely match the actual experimental data, therefore showing that air resistance does affect projectile motion. However, as you will later see, the experimental data was actually closer to the model without air resistance, and that was due to various sources of error, which I will also explain later. For this lab, the system is a crumpled piece of paper, and the surroundings include air and the earth. We will make the assumption that the crumpled paper has a uniform mass because we didn't have access to a perfectly ideal sphere. We're also going to use Newton's second law, which allows us to describe the motion of any object in terms of the forces acting upon it. In this lab, the two primary forces that we're going to consider are the force of gravity and the force of drag. As shown in the slides, the force of drag is equal to negative bv squared, and by definition, it acts in the direction opposite to the object's motion. Our initial conditions are in the y direction, we have both the force of gravity and the y component of the drag force, and in the x direction, we only have the x component of drag force. A free body diagram shown is one on the left. The free body diagram on the right is what it looks like at the end of the motion, where drag is pointing upwards. Shown on the slides is my tracker analysis, and as you can see, I set the meter stick as our reference length, and the magenta axes are right below where I started the object. I chose to start tracking a few frames after the ball was released to minimize the amount of initial force, to minimize the influence of the initial force applied to the object. And from tracker, as you can see, I got x values, y values, and velocity and acceleration data. Now for the computational data, since the goal of our lab is to analyze how the force of drag affects motion, we're going to create two models, one that includes drag and one that does not. When we compare these models to our actual experimental data, then we can see which is more accurate. So in my code, the initial position is taken from tracker at time 0, and the initial velocity is calculated using the first two data points. And then we're going to set the frame rate 0.01 seconds as our time step. Additionally, we define both the forces of gravity and drag. So for the first model, we can eliminate drag